Hello and welcome. In this video, I would like to show you how the shape and structure of cities affects the reuse of water, nutrients and carbon. I guess you have heard about the fact that more dense cities are likely to be resource efficient. Per inhabitant, they afford to use less energy, construction materials, pipes and other things. You have also heard that it's proposed that cities are good places for reuse of resources because firstly, there are many resources concentrated, and secondly, because there is a close proximity of supply and demand of resources. For nutrients, carbon and food production, the research on the relationship between cities and their shape and structure is not that far developed. There are many unanswered questions about how a city should look like to best recover nutrients or to reuse carbon that is contained in the organic matter and biomass. One reason for this is certainly that these ideas are relatively recent in the context of the new resource efficient cities. But actually, this is not quite correct. One could say that cities as places for reuse of nutrients and carbon for food production just experience a renaissance. Or indeed, the value of the urban resources has in some places never been forgotten, like here in India or Pakistan, where in 2004 about 26% of all the vegetables were grown in untreated wastewater. Or in other Asian cities where wastewater is used for agriculture production. But coming back to the idea of shape and structure, at least one relatively old but famous example exists where a relationship between urban design, water, nutrients, and food is made. This is the idea of Sir Ebenezer Howard, the Garden City. In 1880, Ebenezer Howard looked at the current cities and recognized the urban ills. He saw that cities were dirty and unhealthy places to live. As a solution to this problem, he suggested the Garden City with parks, green spaces, and areas for food production from within the city, but also a better connection to the surrounding farmland. If you look carefully at this sketch of the Garden City, you will recognize that there are many reservoirs that can provide water for the city. There are large farms that can supply food and also receive the human excrement. This setup does not only help to generate the products for the city, but it also allows the land surrounding the city to degenerate the wastes of the city. Indeed, Howard's idea was a city in balance with nature and its hinterland. There are many examples for garden cities around the globe, and there is and was a lot of critique on the garden city. Much of this critique is related to aspects of density, which is reflected in the trend towards dense, compact, and thereby efficient cities. But one can argue that the garden city idea survived and has found new support in the current urban agriculture movement, where urban agriculture is defined as an industry located within or on the fringes of an urban area, which grows, raises, processes, and distributes a diversity of food and non-food products. It should be reusing mainly resources found in and around that urban area, and in turn, it should be supplying resources, products, and services to that urban area. The interesting thing about this definition is, on the one hand, that it describes an industry, so highly intense and large scale. But the current reality of urban agriculture is often different and more subsistent or hobbyist, like here in Paris, at a very small scale between two buildings. But there are as many definitions as there are types of urban agriculture, some of which are indeed industrial, like here in the Rotterdam harbor. Nonetheless, an important characteristic of this definition is that cities should be capable to reuse nutrients within its boundaries or close by. Therefore, the availability of unused or vacant spaces, so-called brownfields, within cities to produce food is crucial. But of course, also on rooftops, food can be produced, like here in Chicago. Furthermore, following the definition above, the urban agriculture should make use of the resources found in the city, including nutrients and carbon that come available in the city. One study investigating specifically the urban form parameters that enable the recovery of nutrients and carbon from household waste and wastewater shows that population density and urban layouts affects costs and feasibility of implementation of resource recovery infrastructure. With higher densities, costs usually go down, while a more compact housing layout requires shorter pipes per inhabitant and dwelling space than a less compact one. At the same time, the study suggests that some treatment systems require more open space or communal areas for installation of treatment and recovery options. This is, for instance, the case for urine tanks or constructed bedlines, as shown here. More open space is indicated by a shift to the left in this diagram. However, as you can see, a lot of open space, indicated by a low ground space index, does not go well with the definition of urban. And open space is often difficult to find in urban areas as there is a high demand and high competition for the use of space. Also, whether a building is high or low rise affects the implementation of collection and treatment systems. For instance, for technologies like composting and dry toilets, there's little experience with these systems in multi-story buildings. But of course, agriculture in the center of the city can only do so much. And the current reality of the waste stream processing is that it happens to a large part on the fringes of the city. Exactly this may be an opportunity, because just like Howard suggests in his garden city idea, and as shown here on the example of Letchworth, the areas outside the cities are where land is available to produce food for the city. In combination with new methods for intensive agriculture, the share of food these areas can supply could be enhanced. In some areas of this world, people on the city fringes even go to court to get their right to wastewater from the city, as was, for instance, the case in Pakistan. Other ideas even emerge how cities can support food production. In the Netherlands, the CO2 from power plants and industry is used in greenhouses to increase agricultural production. Or some researchers even have the objective to close the nutrient, water, and energy cycles by linking urban areas to greenhouses. These greenhouses take up water and nutrients, provide food, produce drinking water from condensation, store and supply heat and cold to buildings, and they produce biogas to generate electricity and heat. But the shape and structure that best facilitates this sort of interaction is not yet known, and many other problems need to be solved before. So, in conclusion, the jury is still out as to how a city that is able to reuse its organic materials and nutrients must look like. It will depend to a large part on the technology selected and the ideals of the people within the city. There may be cities that are green with punctuated open spaces for food production. But in parallel to this, there are likely to be cities that produce food in its surrounding landscapes. In these cases, it is then important to protect this land from urban development and to connect waste and wastewater processing to agricultural production. So, when will you start farming the city?